Yeah, so this is a question from GATE 2019. The question is, let h of z be the z transform of a real valued discrete time signal h of n. If p of z equal to h of z into h of 1 by z has a 0 at z equal to 1 by 2 plus 1 by 2 j, and p of z has a total of 4 zeros, which one of the following plots represent all these zeros correctly? So we need to find what are the zeros of p of z, right? So given we have p of z equal to h of z into h of 1 by z, right? And given the p of z has 4 zeros, right? So since p of z is a multiplication of h of z into h of 1 by z, we can say like h of z will be having 2 zeros, and similarly h of 1 by z will be having 2 zeros, right? Remaining 2 zeros. So for example, let h of z has 0 z1 and z2, and h of 1 by z will be having the zeros z3 and z4, right? So we need to find what is z1, z2, z3 and z4. That's it. Okay, so let us take the h of z. Okay, and given p of z is having 4 zeros, and one of the zero is this one, z equal to 1 by 2 plus 1 by 2 j. So let that be the zero of h of z itself. So z1 equal to 1 by 2 plus 1 by 2 j, right? That is the zero. So if you could see here, this is a complex number. So definitely what will be the second zero? Z2 will be its complex conjugate, right? Z1 star. So this will be equal to 1 by 2 minus 1 by 2j. So definitely this will be the other zero. Now coming to h of 1 by z, right? The other two zeros, definitely z3 will be equal to 1 by z1, right? It will be the inverse of z1 itself, right? So what will be that value? This will be equal to 1 by 2 plus 1 by 2 j, right? So this is equal to, I can take 2 outside, 2 by 1 plus j. So I will make the denominator to be a real value. So 2 I will just multiply with 1 minus j. So this will be 1 plus j into 1 minus j. So this is equal to 2 into 1 minus j. So denominator is like a plus b into a minus b. So a square minus b square. So 1 plus 1 is 2, right? So this 2 and this 2 will be cancelled. It will be like 1 minus j. So z3 is 1 minus j. What will be z4? Z4 will be equal to z3 star, that is conjugate of this, right? So it will be 1 plus j. So these are the two zeros of h of 1 by z, and these are the zeros of h of z. So how the pole zero plot will look like? So this is real of z and imaginary of z, right? So let this be 0, is 1 by 2, this is 1, this is 1 by 2 1, this is minus 1 by 2 1, minus 1, right? So the first pole is at 1 by 2 plus 1 by 2j. So this is 1 by 2 and this is 1 by 2j, right? So the first pole will be here, right? And its conjugate will be where? It will be here. And z3 and z4 is at 1 plus j and 1 minus j. So 1 plus j is here and 1 minus j is here, right? So this will be the zeros of the p of z. So in the option, if you could see here, d will be the answer. So where d, you could see the four poles, z1, z2, z3 and z4, right? Yeah, so this is a question from GATE 2019. The question is, consider the signal f of t equal to 1 plus 2 cos pi t plus 3 sin 2 pi by 3t plus 4 cos pi by 2t plus pi by 4, where t is in seconds. Its fundamental time period in seconds is. So we need to find what is the time period of the signal f of t. So let me write f of t here. F of t equal to 1 plus 2 cos pi t plus 3 sin 2 pi by 3t plus 4 cos pi by 2t plus pi by 4. Right? So to find the time period, so here if you carefully see, we have 1 which corresponds to DC offset, right? So it won't affect the periodicity of the signal, right? And we have 3 sinusoidal components. So I'll call this as x1 of t, I'll call this as x2 of t, and I'll call this term as x3 of t, right? So what is x1 of t? X1 of t is 2 cos pi t, right? So what is the frequency of the signal? So usually any sinusoid, so sine or cos, okay, it is sine 2 pi ft with a frequency where f corresponds to the frequency, right? So comparing this, so with this equation we can find the frequency of this signal. So what is the frequency of this signal? So I'll call it as f1. F1 is given as, so this should be 2 pi ft. So what is f1 will be equal to 1 by 2. So if f1 is 1 by 2, its corresponding time period t1 is equal to 1 by f1, that is 2, right? So time period of first signal x1 of t is 2. Similarly, I have x2 of t, this is equal to 3 sin 2 pi t by 3, right? So similar to the previous, the frequency of this signal x2 of t, I will call it as f2. This is equal to, this will be equal to 1 by 3, right? Which means its time period t2, I will call t2 will be equal to 1 by f2, that is 3. Similarly, I have x3 of t equal to 4 cos pi by 2 t plus pi by 4, right? So this pi by 4 is just a phase shift. It won't create any change in the frequency of the signal, right? So similar to the previous, the frequency of the signal, right, f2 of the frequency f2 will be equal to 1 by 4, right? So the corresponding time period of the signal, so this is f3, sorry, not f2, the time period t3 will be equal to 4, right? We need to find the fundamental time period of the signal, and this time period is valid only if the signal is a periodic. So how to find whether it is periodic? We just need to take the ratio of t1, t2, t3 and whether it is rational. So the ratio of this signal t1, t2 and t3, it is definitely a rational number. Why? Because it is 2, 3 and 4, right? So definitely it will be periodic. So if it is periodic, so what is the period of the signal given is f of t, right? Period f of t, so I'll call it as t. This is equal to, we know the time period will be equal to LCM of t1 comma t2 comma t3. The time period t is as LCM of t1 is 2, t3 is 3 and sorry t2 is 3 and t3 is 4, right? So what is LCM of 2, 3 and 4? That is 12. So time period of this signal is equal to 12, right? So answer is 12. Yeah, so this another question from GATE 2019. The question is, consider a 6-point decimation in time Fourier fast Fourier transform FFT algorithm for which the signal flow graph corresponding to x of 1 is shown in figure. Let w6 equal to e power minus j2 pi by 6. In figure, what should be the values of coefficients a1, a2, a3 in terms of w6 so that x of 1 is obtained correctly? So given n is, right, so given n is equal to 6 because it's a 6-point decimation time fast Fourier transform DFT, right? And we have the 6 inputs. x0 to x6 x5 and we have the 6 corresponding DFT output right here. So these are the input nodes, these are the intermediate node and these are the output nodes, and we need to find what is a1, a2, a3. That is a question, right? So let this intermediate node value be given as a, let this be b and let this be c, right? So from figure it's clear that what is a is like it is formed by x of 0 and x of 3, right? X of 0 into 1 plus x of 3 into minus 1. So I can write a as a equal to x of 0 minus x of 3, right? Similarly b is x of 1 minus x of 4, and what is c? C is formed by x of 2 and x of 5. So c is x of 2 minus x of 5, right? So what will be x of 1? X of 1 will be, right, from figure it will be a1 into a plus b, a2 into b plus a3 into c, or if I substitute the value of abc, it will be a1 into x of 0 minus x of 3 plus a2 into x of 1 minus x of 4 plus a3 into x of 2 minus x of 5, right? Now we also know what is the standard DFT equation. So x of k, right, x of k is given as summation n equal to 0 to n minus 1 x of n into e power minus j2 pi by n into nk, right? So where here n is 6 and I can write e power minus j2 pi by n or 2 pi by 6 as w6, and here our objective is to find what is x of 1. So what is x of 1? X of 1, that is for k equal to 1, x of 1 I can write as summation n equal to 0 to n is 6, right? So n equal to 0 to 5 x of n into e power minus j 2 pi by 6 into n, and here I will substitute e power minus j 2 pi by 6 as w6, so I can write as w6 of n, right? So let us expand this. So once I expand this, what I will get? X of 0, so n equal to 0 I will put into w6 power 0 plus x of 1 into w6 power 1 plus x of 2 yeah. So what is w6 power 0? It is e power minus j 2 pi by 6 into 0, that is 1, right? Now before finding these two values, let us find what is w6 power 3. So w6 power 3 is e power minus j 2 pi by 6 into 3. That is 2 3 is 6, so it will be e power minus j pi. So this is minus 1. Similarly, what is w6 power 4? That's the fifth term. So this is equal to w6 power 3 into w6 power 1. Right. So already I know what is w6 power 3. It is minus 1. So minus 1 into w6 power 1 or minus w6 itself. Right. Similarly, w6 power 5 will be w6 power 3 into w6 power 2. Right. So 3 plus 2 is 5. So already I know w6 power 3 is minus 1. So that into w6 power 2. So it is minus w6 power 2. Right. What happens to this equation? This equation I can rewrite as x of 1. I can write as x of 0 is 1. So w6 power 0 is 1. So x of 0, right, plus x of 1 into w6 power 1 plus x of 2 into w6 power 2 plus now w6 power 3 is minus 1. So minus x of 3, right, plus x of 4 into minus w6 power 1 plus x of y into minus w6 power 2. So let us club this term. So I will get x of 0 minus x of 3, right, plus I can club these two terms. So x of 1 minus x of 4 into w6 power 1 plus I can club the rest terms, that is x of 2 minus x of 5 into w6 power 2. Right. So this will be x of 1. Right. Now if I compare this with this equation, I will get a1, right, a1 to be equal to 1 because this is into 1. Right. What is a2? A2 will be equal to w6 power 1 and a3 will be equal to w6 power 2. Right. So this will be the coefficient a1, a2, a3. So if we see here, the answer will be equal to C.